Yesterday I had posted about setting up overheating protection for this HF linear amplifier which I had homebrewed. And I bought this from Amazon. This is a thermostat board. Surprisingly, this was purchased only yesterday evening and today morning it arrived. So it is presumably being stocked somewhere near. This is the probe, temperature probe. VO3GZR is implementing this in a different way. He has tied this on one of the MOSFETs, output MOSFETs, that is the power MOSFETs, and he's using this to switch on a fan, additional fan. One fan is already there, second fan gets switched on in his linear amplifier when the temperature goes beyond a set level. This is the probe which can be pinned in here. This is the slot for pinning in the probe. I already connected the probe here, and this is a magnified view to see the what is written on there. This is a ground connection plus 12 volt connection, and this should be the relay connection for switching the amplifier or bias or whichever I choose to switch. This is the set button, and there is plus and minus. Now I have connected 12 volt battery. This is the 12 volt battery. You can see this 12 volt battery, and temperature shown is 29.6 degrees centigrade. For comparison, I have kept my humidity temperature meter here. It shows 29.7. So that should be fairly accurate. Now let me see whether it will change if I hold it. If I hold it, temperature should increase because it will show my body temperature. I will see how much it will increase. It has increased initially very fast, but then the increase will not be very fast because heat transfer will take time, especially from the fingertips. It will not be fast because fingers have thick skin and insulation. So anyway, the temperature probe is working. I thought of putting it in hot water and testing, but then I thought of a simpler way. Just by holding it, the temperature will rise. So this should be working properly. It is about 33.4. That's not exactly body temperature. Body temperature should be 37 degrees centigrade. But anyway, it is gradually going up. So I am stopping this test here. To change the temperature settings, press this set button first. Display starts flashing. Now you can increase it. I am increasing the temperature setting in steps. It has reached 45.1 degrees centigrade. By default, this is in the cooling mode. I am going to change the program. There is a long press here for 5 seconds. Then PO is displayed. PO is the program. That is P0. I am long pressing the set button. Then P0 is displayed. Again set button. This is cooling mode. I have to change. Now I have changed it to heating mode. Then again back. Now it's in the heating mode. Now it is P0. I want to change the program to P1. P1. This is P1 now. The hysteresis is set at 2 degrees centigrade. That means switch will work when the temperature is 2 degrees beyond the cutoff. You can see that now this is connected. That is between K0 and K1 it is connected. I will enlarge and show. This is K1 and K0. So the switch is on when the temperature is 28.3. I am trying to warm it. See, the thermostat has cut off. That is because I have set a temperature in such a way that when it is nearing 32, it will cut off. I set 32 not because it is the limit for my MOSFETs, but this is easy to demonstrate. So this has been cut off. The switch has been cut off. Now I rapidly bring it down by putting it on ice. Cooling is easier if I put on ice. That's why I am doing that. You can see that now when the temperature has come down, it has switched on. So this is the mechanism which I am planning to use in my linear amplifier as well. I'll take it out and show once again, but this time it will take more time because ice has been used. It will not warm up so fast. Let me see. Yes, it is warming up. But it has not reached the 32 level cutoff. Oh yeah, it has cut off. You can see that it has cut off once again. So this is the principle. Now what I like to do is that this relay has a rating of about 10 amperes, and I like to use probably a higher rating relay to switch the radio, because radio may use more than 10 amperes at peak power output. For idle current, this is more than enough. But full power, that is 100 watts on 12 volt radio, it will take more than 10 ampere. So I'll need another higher rating relay to switch